I'm Professor Rad, and this is Precalc video 3.5, the unit circle. In this video, we're going to be doing a lot. So we're going to talk a little bit about the origins of the unit circle, where the values on the unit circle come from, and then we're going to be talking about a technique for labeling particular values on a unit circle. Now, when we go to find these values, these are values you are expected to know. So you'll be expected to know these exact values that fall on the trig, on the unit circle. So let's start out. We're going to ignore these triangles on the side for a minute, and we're just going to focus on the first quadrant of our unit circle. So this is our x-axis and our y-axis, and this is the top right quarter of our circle. So the reason we're going to focus on this to begin with is if I look at this side here, that's on the x-axis. This would represent an angle of 0 degrees or 0 radians. So the x and y values for that point are 1, 0. So we have an x value of 1 and a y value, oh goodness, of 0. Sorry, my cat is a little bit feisty at the moment, apparently. So once we have the x value and the y value, remember that on the unit circle, sine of theta is the same as y, cosine theta is the same as x, and tan theta is the same as y over x. So once we have the x and y coordinates of that point, we can figure out sine, cosine, and tangent. So sine is the same as the y value, so sine of 0 is 0. Cosine is the same as the x value, so cosine of 0 is 1. And tangent is y over x, so 0 over 1 is 0. So we can find those values for this point. It's easy for us to know those coordinates. Similarly, we can find the value for 90 degrees. Now remember that we have the relationship that 180 degrees is equal to pi radians. So if I cut that in half to get 90 degrees, I would cut the radians in half to get pi halves. So now that I'm here, I have an x, y value of 0, 1. So down here, I'm going to write my x value of 0 and my y value of 1. Now that I have these, I can apply those definitions to find sine, cosine, and tangent. So sine is the same as the y value, cosine is the same as the x value, and tangent is going to be y over x. Now in this case, that gives us 1 over 0, which is not defined. So tangent of pi halves is undefined. All right, so there we go. Those are our trig functions for the positive x-axis and the positive y-axis. Now, I'm not including cosecant, secant, and cotangent here because those are just the reciprocal relationships. So I'm just including these three because these are the three main trig functions. I will also mention that if you are taking a pre-calc class with me, remember that trig fact sheet that we've been working on. So we have filled out the whole first page. Now we are working on the second page at the bottom. So this is what we're filling in right now. We'll fill in the top later. So we're working on the bottom piece. All right, so next, suppose like we took 180 degrees and cut that in half to get 90 degrees. Let's say we cut that in half again. So half of 90 is 45 degrees. And half of pi halves is going to be pi fourths. So I'm going to use this middle line here since we're going halfway here. This is going to be pi fourths radians, which is the same as 45 degrees. So this is going to bisect this quadrant here. So we have 45 degrees plus another 45 degrees will give us 90 degrees. Okay. So now that we have that angle drawn, now we're going to refer to our isosceles right triangle up here. So here we have two 45-degree angles and our right angle of 90 degrees. And the sides of this triangle are 1, 1, and root 2. Now we do have a little bit of a problem, and that problem is we're working on a unit circle. So we want to have the radius of this circle equal to 1. So in order to achieve that, that means that on this triangle, we need to scale it so that the hypotenuse, that's our radius, is equal to 1. So to do that, I'm going to divide each of these values by root 2. When I do that, I now have my hypotenuse of 1. And 1 over root 2 is the same as root 2 over 2. And same thing here, this is root 2 over 2. So if I know my 45-degree right triangle, then I can make a relationship here to the unit circle to find the x value of root 2 over 2, because remember this is x, and the y value of root 2 over 2, because this is y. And we can achieve that because, again, our radius has to be 1. So that's why we had to divide by root 2, so that we would get a radius of 1 here. But now that we have that, our x value is root 2 over 2, and the y value is root 2 over 2. So we can fill in our x and y values here, root 2 over 2, root 2 over 2. Then we can fill in our sine and cosine values, because sine is y, so sine is going to be root 2 over 2, and cosine is x, so cosine will be root 2 over 2. For tangent, tangent is the same as y over x, but because x and y are the same value, that means tangent's just going to be 1. So tangent of 45 degrees or tangent of pi fourths radians is going to give us 1. Okay, so next, I'm going to envision dividing the circle up into, let's see. So if I think of my half circle here, when I divided it in halves, right, that gave me the 90 degrees. So now I'm going to pretend I didn't divide that half in half. Instead, I'm going to divide this half into thirds here. Right, so think of it as here's 1, 2, and 3. So I'm going to take this quarter circle, which was 90 degrees, and divide it by 3. So pi halves divided by 3 is going to give me pi over 6. And 90 degrees divided by 3 is going to give me 30 degrees. So this is what I'm going to write up here. This is a 30-degree angle. And then this is pi over 6. When I draw that here, I want to take this whole quarter and divide it into thirds. So that's about here. And now we're going to need to figure out what are the coordinates of that point. That's what we're going to look at next. So to help us achieve this, we have a 30, 60, 90 right angle. So on a 30, 60, 90, one side, the side across from the 30 is a 1. The adjacent is root 3, and the hypotenuse is 2. Now, just like our 45-degree triangle, we want to make sure that we have a radius of 1. So because this hypotenuse is 2, we're going to divide all of these values by 2. That will give us our radius value of 1. The opposite side is now 1/2, and the adjacent side is root 3 over 2. So this is good news for us because it means we don't have to simplify any radicals because they're already in simplest form. Yes. Okay. So on this triangle, the adjacent is the same as the x value, and the opposite is the same as the y value. So that means that x is going to be root 3 over 2, and y is going to be 1/2. So for 30 degrees, x is going to be root 3 over 2, and y is going to be 1/2. Now, something I like to do is to check to make sure that this answer seems reasonable. So if I'm looking at this point and I come over to the y-axis, even though my picture is not perfect, it does look like that y value is about halfway up. So my y value is 1/2 and my x value is √3/2. Now that we have the x's and y's, we can go ahead and find all of our trig values. So sine of theta is y, so this is 1/2. Cosine of theta is x, so that's going to be √3/2. And Leonard, you're going to calm down. And then tangent is going to be y over x. So we have 1/2 over √3/2. So we're going to multiply top and bottom by 2, and that will give us 1 over √3. Oh, we do have radicals to simplify. So multiplying top and bottom by √3, we're going to get √3/3. So that means that tangent of pi/6 is going to be √3/3. Okay. That leaves us one blank spot left for us to fill in. So I'm going to erase the green so I have some more room to work. And this time what I'm going to do is, instead of envisioning just the first quadrant divided into thirds, I'm going to think about the whole top being divided into thirds. Okay. Ronnie wants to participate today. So if I divide the whole top into thirds, it's going to be about here. Right? So that's about 1/3. So if I do 180 divided by 3, that's going to give me 60 degrees. And if I do pi divided by 3, that's going to give me pi/3. So this last angle that we have is 60 degrees, which is pi/3. In terms of where that will be on this image here, 1/3 or pi/3 is the same as 2/6 or 2 pi/6. So I can think about doing 2 of those angles, and that will get me about up here. So now this is my angle for pi/3 or my angle of 60 degrees. So the good news is that I can use my 30, 60, 90 triangle again to help me figure out the values. I'm just going to backtrack a little here. So now we want this hypotenuse to be 1. So I don't know why I erased dividing by 2. We're going to need that to work. So we're going to go back to those values. Now this time we have to be careful because the way this triangle is oriented can be a little bit confusing for the 60 degrees. Remember that the adjacent side is the same as x. So adjacent side is x. So that means for a 60-degree angle, x is 1/2, and the opposite side is y. So that means y is going to be √3/2. So for 60 degrees, we have the same coordinates as for 30, but flipped. So we're going to have 1/2 for our x value and √3/2 for the y value. Again, if I check how I've drawn this, I go down here, my x value is about halfway through. So even on my really sketchy, sloppy half circle here, we're able to get that correct-ish. And now we just play the game. So we're going to fill in according to the formulas. So sine is y, so sine is √3/2. Cosine is x, so cosine's 1/2. And tangent is going to be sine over cosine. So we're going to get √3/2 over 1/2. Oh, this one's easier to simplify because if I multiply top and bottom by 2, I get √3/1, which is just √3. So tangent of pi/3 is going to be √3. Ta-da! So That's it for the first quadrant of the unit circle. So I'm going to get out of the way for a minute here. So if you want to pause right now so you can copy all of this down, feel free to do so. So you need to find a way. Oh, I didn't write it out. Forgot this one spot here. So this point here is going to be 1/2 root 3 over 2. There we go. So now we'll get out of the way. If you want to fill in that blank there, you can. Okay, so what you're going to need to do is to find some way to remember all of this information. So I've mentioned in a previous video that I have a really tough time memorizing stuff. So this was very hard for me. So I'll share with you something that I used to remember this, and then I'll share with you some things that students have told me that have helped them as well. Okay, so as long as you know X and Y, and you know your definitions, you can figure out everything else. So really the key to this is knowing where the angles fall. So knowing that in the middle here is pi-4ths, and then you have pi-6 and pi-3rds, or 30 degrees and 60 degrees. So what helped me to remember this is that the denominator and the degree don't match. So pi-3rds is 60, pi-6 is 30. And then if I could envision 30 degrees being smaller than 60 degrees, I could figure out where pi-6 and pi-3rds was. So that's what I used at first to remember where those radian measurements are going to go. And then I just remembered pi-4ths is 45, so that cuts it in half. And pi-halves brings you on the y-axis. So that's how I remembered where the angles are. Then to remember the y values, you need to remember some stuff. You do have to memorize some things. So I had to remember that the numbers 1/2, root 3 over 2, root 2 over 2. That's what I had to remember. So I have to remember, ooh, something in my eye. Oh goodness. Yes, Lenny. So I had to remember these values here. As long as I remembered those, then I would be good to go. So I remembered root 2 over 2, that's a lot of 2s, so it's 2 coordinates that are the same. So root 2 over 2 and root 2 over 2, those are the partners. Then I remembered that 1/2 and root 3 over 2 are the other partners. And genuinely, the only thing I could do to get those to stick in my head is to look at it visually and see which one looked to be 1/2. So if I look at this angle here, the x value for this point is down here. That's much bigger than 1/2, whereas the y value is 1/2. So that's how I knew this one was 1/2 and the other one was root 3 over 2. And then the same thing with this one here. So if that sort of visual relationship works for you, that's a way to go. If you're like, nope, no good, here's something that a student told me that helped them out. So you have your unit circle or your first quadrant written out this way. And if you start at the top, so start at the top, your numerators are 1, root 2, root 3. And then going back up, 1, root 2, root 3. And they're all over 2. So if you can remember that, starting at the top, you have 1, 2, 3, 1, 2, 3. That's another way that you can remember the coordinates of your unit circle. And lastly, if you remember your 45 triangle or your 30, 60, 90, you can use that information to help you too, right? You can derive these values just like we derived them just now. So any of those techniques can help you out. Okay, so to finish this video, we're going to go on to the next page of our packet, which has the full unit circle on it, and we're going to fill in all of those values. It's going to be interesting on my tiny board, but we're going to do our best to try and fill in all of those values. So give me and Lenny just a moment to erase the board and set that up. All right, so let's go through drawing a unit circle. To begin with, I like to label my quadrant values. So what that means is I'm going to label this point here. This is my point 1, 0. Up here, we have 0, 1. Then over here, we have -1, 0. And then down here, we have 0, -1. When you divide a circle into quarters, into quarters, you're dividing the radians by halves and you're counting by 90 degrees. So this would be 0 radians and 0 degrees. Up here, now I've moved, I'm going to put the, I think I'm going to put the radians on the inside of the circle and the degrees on the outside. So I'm going to put pi-4ths radians here, or pi-halves, oh my goodness, pi-halves radians, which is 90 degrees. Then another pi-halves gives me pi radians, which is 180 degrees. And then another pi-halves is going to give me 3 pi over 2 radians, which is 180 plus 90 is 270 degrees. And then we come back over here, and that's for a full 2 pi, which is 360 degrees. Now, one thing I do want to point out is that although 0 radians and 2 pi radians are coterminal, so those angles end at the same point, they are not the same angle. 0 radians means you don't move at all. 2 pi radians means you've walked in a whole circle. So similarly, you could think of it as like -90 degrees and 270 degrees. Those are coterminal because they end at the same point. But -90 degrees is walking this path. Positive 270 degrees is walking that path. Okay, so just be careful about that. Next, when I'm filling in my unit circle, I like to fill in the 45s because that's halfway between. So let's fill in our 45s. So we're going to divide this. Now, instead of being quarter circles, it's going to be divided into 8s. And what I'm going to do just for reference right now, I'm going to write pi over 4 as my spot for there. Now I'm going to draw the lines for pi over 6. So remember, pi over 6 is the same as 30 degrees. So that's taking this quadrant and dividing it into a third. So that's about here. So I'm going to draw a line like this. And then I'm going to draw another line. Think about reflecting it over here. So we have something, not doing the best job of drawing these lines tonight, but there we are. So this one here is going to be pi over 6. I'm just going to draw the dots on the other ones. And then in blue, I'm going to draw the pi thirds. So pi third is like dividing the top half into thirds, or it's like 2 pi 6. So we're going to get something like this. And I'm running out of room here, but that's my pi thirds. All right. Okay, now before I put in the quadrants, let's label all these angles. So what I'm going to do is I'm going to count by the pi fourths first. So I'm going to ignore the green and the blue lines. I'm just going to be counting by pi fourths. So remember that it's 2 pi fourths will get me to pi halves. So what I'm going to do is I'm going to count by quarters. You can ignore the pi if it bothers you, right? So you could think of this as 1/4, 2/4, which is a half. And now here we're at 3/4. So that gives me 3 pi over 4. So 3/4. 4/4 is 1. 5/4. So this is 5 pi over 4. 6/4, which is the same as 3/2. 7/4. So this is 7 pi over 4. And then 8/4, which is the same as 2. So as I go around, I'm counting all the black lines and the red lines. Those are my quarters. So we have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. So that's how we label our quarters. Next, let's label our thirds. So the thirds are the blue lines and the horizon. So here's my 1/3, right? Because that's a third of the way through the top. I skip over that middle line. And then over here, this is going to be my 2/3. So 1/3, and here's 2/3. So that's 2 pi over 3. And then when I get to pi, that's now my third third. So each of these arcs is a third of the top half. Then we go the same thing on the bottom. So from here to the next blue line. So this is 1/3, 2/3, 3/3. Now we're at 4/3. So that's 4 pi over 3. Over here to the next blue line is 5 pi over 3. And then here we have 6 pi over 3, but 6 over 3 is 2. So that's our 2 pi. So when we're counting thirds, we're counting the horizontal black line and we're counting the blue lines. So 1, 2, 3, 4, 5, 6. That's how we're getting our thirds. And let's see, lastly, we have to measure the sixth. So for the sixth, we're going to do everything except for the red. So for the sixth, this is 1/6, 2/6 is a third, 3/6 is a half, 4/6 is 2/3, 5/6 doesn't simplify. So 5 pi over 6, 6 over 6 is 1, 7 over 6 doesn't simplify, so we have to write that one. 8 over 6 is 4/3, 9 over 6 is 3/2, 10 over 6 is 5/3, 11 over 6 doesn't simplify, so we have to write it, 11 pi over 6. And then 12 over 6 gives us 2. So that's how we count out the sixths. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So when you're counting through, also use the arc lengths to help you make sure you're moving the same amount of space each time. So when I count my pi 6, I want to make sure I'm going, here's about that length, right? So that's 1/6. Here's the second 6. Here's the third. So here's my first 6, my second 6, my third, fourth, fifth, and sixth. Okay. Okay, so those are the radian measurements. Now we get to fill in all the angles, the degrees. So pi over 6, that's the same as 30 degrees. Okay, I'm going to put a space here for my x, y values. So that's 30 degrees. So every time I go a sixth, I'm moving another 30 degrees. So if this is 1/6, here's my second sixth. So I'm going to put x, y values here. That's 60 degrees. And then 90. Add another 30. And that will get us 9, 10, 11, 12, 120. Then for this green line here, add another 30. So 20 or 12, 13, 14, 15, 150. Add another 30 to get to 180. 18, 19, 20, 21. So this one's going to be 210. Plus 30 is going to give me 240 here. Drop this one down a little bit further here. So that's 240. Plus 30 gets me this 270. Plus 30 for this point will get me 300. Plus 30 for here will get me 330. plus another 30 brings me up to the 360. So if I go by my pi over 6, that fills in not only the sixths, but also the thirds going around. And lastly, I have the pi fourths left to do. So for the pi fourths, I'm going to put some space here for a point. Pi over 4 is 45 degrees. So now I count by 45s. So 45, 90. Let's see, 90 plus 40 is 130. So we get 135. Plus 45, that would give me 175, 180. Plus 45. So that should be 225. Plus 45 will get me 270. Plus 45. So that will give me a 315. And there we go. So that's how we can fill in our degrees, okay? Just by kind of adding and going around. Okay, so those are our radians, those are our degrees. Now, typically when you create your unit circle, you're going to focus on your first quadrant, and then you're going to focus on reflecting where you need to be. So let's use the trick that my student taught me for remembering how to fill in the values in quadrant 1. So starting from the top, we have 1, root 2, root 3, okay. And they're all over 2. So we have 1, root 2, root 3, and now going up, we have 1, root 2, root 3. All right, so that's how we can fill in the values of those ordered pairs up in the first quadrant. To fill in the rest of the circle, now you want to think about reflecting each of those lines and whether that's going to make the x and y value positive or negative. So I've got my blue marker in my hand, so I'm going to start out with the blue lines. So notice how if I take this point and reflect it over here, it has exactly the same y value, but the x value is now going to be a negative number because it's in the second quadrant. So the y value stays root 3 over 2, but the x value becomes a negative 1/2. In order to fill in the points here, now I have the same x value. So the x value stays a positive 1/2, but the y value becomes negative because I'm in quadrant 4. So the y value is a negative root 3 over 2. And lastly, to figure out this one, I can reflect either the one from quadrant 4 or quadrant 2, whichever you prefer. So if I reflect this one, the x values are the same. So it's going to stay a negative 1/2. And the y value is going to stay a negative root 3, or it's going to turn into, sorry, a negative root 3 over 2, because now we're in quadrant 3. All right, and that's how we're going to fill in all of these. So for the red ones, when I reflect from here over to this quadrant, y is the same, but x is negative. So we get negative root 2 over 2, positive root 2 over 2. When I reflect this point down here, the x value stays the same. So we have a negative root 2 over 2. The y value now becomes negative, so we have a negative root 2 over 2. And if I move to find out the coordinates of this point, the y value is the same. So the y value stays negative root 2 over 2. And then the x value is now going to turn positive. So we get a positive root 2 over 2. And lastly, now we get to do the green. So these are our pi 6, 5 pi 6, and so on. So for the pi 6, when I reflect it over here, the x value turns negative, but the y value stays positive. So we have negative root 3 over 2, positive 1/2. When I reflect this down here, Now the y value turns negative. So we have both a negative root 3 over 2 and a negative 1/2. And when I reflect it back over to here, the x value now is going to turn positive root 3 over 2, but the y value stays a negative 1/2. So there we go. That's going to be drawing the complete unit circle. So we have the coordinates of all the points, and once we have the coordinates, we can find sine, cosine, tangent, secant, cosecant, cotangent. And then we also have all the radian measures, as well as all of the degree measures. So as long as you know this first quadrant, you can figure everything else out by counting either your degrees or your radians, counting those out, or by reflecting the coordinates of the points. So my recommendation is, if you have an easy time memorizing stuff and you want to memorize this whole thing, go for it. But if you have a tough time memorizing things, then you can go ahead and use this unit circle to help you out. So what I'm going to do now, so I'm going to move out of the way in case you want to pause and copy any of this down. And then I'm going to erase, and we'll do some examples, and I'll show you how you can create the unit circle in a moment to help you to solve the problem. All right, so here we go. All righty, so now we're going to find these 5 values. We're looking for exact values, so we don't want decimal approximations. And we're going to use the unit circle to help us out here. Now, I recommend when you're working on these problems, part of the goal in working on these problems is to help us to memorize and to remember and learn the unit circle. So my recommendation is, do not look at your unit circle as reference. Try to create these from memory. And then once you think you've got it created, consult your unit circle to make sure everything is correct. So what I'm going to do here, I notice that I have pi over 6. So I'm going to focus first on the angle, ignore the cosine for a minute. So for pi over 6, I'm going to draw myself a little mini unit circle. And I know that pi over 6, those are the ones that hug the x-axis, right? So this is 1, 2, 3, 4, 5, 6. So that's kind of what I'm seeing in my head. These are my pi 6. But since I only have 1 pi over 6, I'm just going to draw 1 pi over 6. So here's my 1 pi over 6. Now for this one with pi over 6, to remember my coordinates, this is the one that I remember as it's got a half and root 3 over 2. If I look at the x value and compare it to the y value is halfway up. The x value is a little bit longer. So that means the coordinates here are root 3 over 2, 1/2. So because that's how I remember my coordinates, I can use that as a guide. Otherwise, you can draw in those 3 things and you can remember a half, root 2, root 3 over 2. For cosine, I'm thinking x, so I get root 3 over 2. So that's how I complete that problem. For part B, now we're finding sine of negative pi over 3. So that is a negative sign there. So I'm going to draw my little unit circle. Negative means I'm going to be going this direction, and pi thirds, that means I've got to divide this half of the circle into thirds. So this is going to be, right, so here's where my other, well, it kind of looks like half, but that's where my other third would be, right? So here's 1, 2, 3, so half the circle in the thirds. So for this one, again, I'm going to look at my y value and my x value. My x value looks a lot closer to 1/2 than my y value does. So I know positive x, so positive root 3 over 2, negative y value, or sorry, positive 1/2, my goodness. The x value is closer to 1/2, so we have a 1/2, and then the y value is negative, so we have a negative root 3 over 2. So for sine, I'm thinking y, so this is going to be a negative root 3 over 2. So I know that I'm going through these a little bit quickly. That's because I know my unit circle because I've had lots of practice with this. So again, that's part of the goal in these problems for you, is to practice drawing out a little unit circle, seeing if you can figure out the X and Y coordinates and using those to find the values. Now let's do one more together and then we'll pause and you can try D and E on your own. I want to do this next one together because we haven't done one quite like this yet. So for this one, we have 6 pi. So we've been focusing on fractions of pi, but remember that pi is half a circle, 2 pi is the full circle. So what I'm going to do is I'm just going to count out 6 pi and see where I land out. So here we have 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So that's where I end. So if you have a value that's bigger than the whole way around, you want to make sure that you indicate where those are and then continue to count until you get there. There are shorter ways. So you could say, well, 6 pi divided by 2 is 3. So I know I'm going around the circle 3 times. You could certainly do that if you're comfortable with that. For me, I'm like the brute force method of just counting it out to get to my solution. So now that I'm here, the coordinates of this point are 1, 0. So for cotangent, I remember cotangent, cosine over sine, right? So cotangent, cosine. So that means I'm going to have my X over Y. So I have 1 over 0. Well, that's undefined. Okay. So take a moment, pause the video here and see if you can figure out these other 2 problems. If you get stuck or if you want to just kind of walk through it all together, then you can keep watching. But if you want to give it a go and try it out on your own, pause the video here and try it out. Okay, so let's walk through these 2 together. So for sine of 35 pi over 4, 35 is awfully big. I know that's going to be more than a full circle, but I'm going to brute force my way through it. So with fourths, that means I'm going to divide half the circle into quarters. So I'm looking at these lines, and I'm going to count out 35 of them. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 24, 32, if I'm counting by 8s, 32, 33, 34, oh golly, 35. Now I know that when I have pi fourths, that means I have the root 2 over 2 situation. So the coordinates of this point are a negative root 2 over 2. And then the y value is positive. So that's a positive root 2 over 2. For sine, we want the y value. So we get root 2 over 2. All right, for secant of 7 pi over 2, now we have pi halves. So those are our quadrant angles. So here's pi, this is pi halves. So I need to count out 7 of these. So 1, 2, 3, 4, 5, 6, 7. This is where I end up. And the coordinates of this point are the x value is 0, the y value is -1. So secant is the reciprocal of cosine. So this is going to be 1 over cosine of 7 pi over 2. And cosine I know is x. So this is 1 over 0. So this one is also undefined. All right, there you go. So the more you practice with the unit circle, the easier it will become to draw these little diagrams. So you really do want to become fluent in the unit circle so you can find these values relatively quickly. So that's going to be it for this video. I know it was a little bit long because we're walking through the process of creating these values and deriving them. Fortunately, the next video is going to be really short because we're going to be using our calculators to find decimal approximations for trig values. So looking forward to seeing you then. In the meantime, I hope this helped you to create the unit circle and understand where it came from a little bit better. And yeah, I hope you have a fabulous day. Bye for now.